Welcome to another Chapter 7 video lesson. Just going to give some general notes about confidence intervals when your population standard deviation is known. Uh, the idea with say a 90% confidence interval is that you've got that normal curve look. In the middle is going to be your x-bar, and then you're looking at that 90% middle piece, 5% on top, 5% on bottom. Just like you did in Chapter 6 with 95th and 5th percentiles. Things that we had already looked at was general formula, x bar minus z alpha over 2 times sigma over square root of n, 2x bar plus z alpha over 2 times sigma over square root of n. We looked at two examples with using that, so just going to extend on a little bit further with that concept. First of all, what's noted as the point estimate. This is the say, best approximation for a population value. And those population values are called parameters. For example, x bar for mu. X bar is the point estimate, and mu is the population parameter. So those are just one of them, and then of course S for sigma. Those are our estimates for those true population values. Now, as we're looking at this, in particular that formula up at the top, we have what is referred to as the error amount. Error amount is the most off a score could be, and still contain your parameter, in this case mu. From our confidence interval, the most off it could be, the farthest away. What you can look at there is that the end of a confidence interval, this is the largest value. That's the largest value you can get and still be in the interval. The error amount then is that. That's how far away from the mean, sample mean, that you could be and still have that value in there. So we use the formula then, E equals what we add on and subtract off there. Z alpha over 2 times sigma over our square root of n. That's our error amount formula. Now, a piece that works off of that nicely is what's called the appropriate sample size. Or a desired error amount. What this is really referring to is you will know your error, you'll know your confidence interval, and you'll know sigma. If I know those three things, I can find the appropriate sample size, which is really solve E for N. What I'm meaning there is E equals Z alpha over 2 times sigma over square root of N. Well, if we cross multiply, square root of N equals Z alpha over 2 times sigma, all of that over our error, which then says N equals Z alpha over 2. Make that look a little bit better there. Z alpha over 2 times sigma over E quantity squared. Solving the error formula for N. So kind of to highlight all of our formulas. X bar minus Z alpha over 2 times sigma over square root of N to X bar plus Z alpha over 2 times sigma over square root of N. So our three main formulas here in blue there that you can see. Now, I want to point out you cannot get by without that one. If you can, you're doing really good. So, the idea is know this. Okay, it's too important not to remember. Now, the other part that I want to point out is this is the error amount. If I know my confidence interval formula, I know my error amount. If I know my error amount, then I can solve for N to get the appropriate sample size. So I can get all three of these formulas with just the one. And when it comes time for your final exam, that's a good thing to be able to do. It'll show understanding of your formula and what the error amount means, and that whole piece with the with what that appropriate sample size means. I do want to give you one example here. If we have sigma equals 24.3, using a 98% confidence interval, and we want an error amount of 2.5. Okay. This is the desired error. We have to calculate or find the appropriate n to correspond with that. So these are already determined. This is desired. Determined or defined already. No control. Well, when we're getting ready to look at this, a 98% confidence interval gives me a z alpha over 2. And recall, I can go to that t-distribution table. And I can run down that 98% confidence interval down here to the bottom. And I will find my corresponding z-score, 2.326. So going back to my problem, I get my z alpha over 2 is 2.326. So I've got all my information that I will need using appropriate sample size is z alpha over 2 times sigma, all of that over E, quantity squared. Now it's a matter of substituting in. Z alpha over 2, that was my 2.326. My sigma, 24.3. My desired error was 2.5, and then squared. Plugging that into my calculator, I will get 511.15, ... You always round up. And so we have to use 512. 511 won't quite do it, and I can't go 1500ths of a person. So I have to round up and use that 512. So there's an example of that, and remember all those different formulas. You can key on the confidence interval formula and get everything from there.